Hi there, my name is Jasmine Rucker, and I did topoisomerase as my protein. But first, let me tell you about topoisomerase. Topoisomerase is an essential protein for stress relief during DNA replication and gene transcription. This protein is an enzymatic molecule due to its bonding nature with specific DNA duplexes, which pass through, break, relitigate, wind up, and unwind DNA. Topoisomerase is usually found way in the nucleolus, but can also be found in the mitochondria and the cytoplasm. This protein is found in prokaryotes and eukaryotes, and bacteria, plants, and animal cells all have topoisomerase. And it is considered likely that mutations can happen in both plants and animals. Topoisomerase is a negative hydrophilic protein, and compared to other proteins, it's pretty much even sized. Now let's talk about the mutation. The TOP2B mutation is a genetic mutation that occurs in type 2 topoisomerase. Type 2 topoisomerase is the only type of topoisomerase that can do decantation, the winding and unwinding of genetic material. This mutation causes problems with DNA replication and gene transcription, as well as enzymatic effects. With this mutation, topoisomerase is less found and less active, which can lead to Bielu syndrome and Hoffman syndrome. This genetic mutation can also lead to lower numbers in B cells and NK cells, which is not good for your immune system. Now I'm going to give you analysis of my model. First, we have no mutation. As you can see, it's very uniform. The double helix is double helixing, and our protein is working to wind, unwind, break up, and relitigate when necessary. There will be many more proteins working with this DNA. However, I wanted to keep it simple and just do topoisomerase, which is active here. Next, we have the genetic mutated topoisomerase. This is my genetically mutated topoisomerase. As you can see, the double helix is very chaotic and the proteins are all mixed in, not doing what they need to do. The unwinding and rewinding has become super coiled and twisted all around the DNA format. Because of this TOP2B mutation, the decantation never occurred, meaning the breaking up, the splitting, and the unwinding never happened. So that's why it's all muttered and clenched up. Again, this has no uniform compared to our other, which does have much uniform, or at least it tried to. Overall, the limitations I would say is I did go simpler just because I wanted to make it easy to understand, as well as I didn't get into much of the detail that I wanted to, just because the more detail I got to, the more confusing it was going to be. And I could barely understand it, so I wanted to make it easily understandable for other people. Other than that, that's my DNA project. I will have pictures. I just wanted to get as many angles as I can, so please enjoy the slideshow of my two different models.